part 4. So this is our table. Now, we saw the table there. Now, this is, as I said to you, this is going to be a 5 by 4 table. The number of columns are the number of x's from 1 to 5. And the number of rows is the number of x's from 1 to 5. And the number of columns is always 4, because I have got only 4 pH parameters. Now, so far we have seen some things. Now, we have seen that alpha and A are 0. Okay. Also, since I've got a revolute joint here, okay, I should have a theta. And in the second one, since I've got a prismatic joint, I should have a D parameters. And let us now start to ask what is alpha 2 first, or alpha 1. So in each case, we look at the index and we look at the I value, and let's decide what is this. So this one is the first one was here, alpha 0. I'm looking at the alpha column. The second one is alpha 1. We haven't answered the alpha 0 as 0. We have also answered the alpha. So we are going to answer the alpha 1. Okay, maybe I'm going to put this a little bit. Maybe I'm going to minimize this now to see the right hand type. So what is theta 1? Let us first answer this question. Now, can anybody answer what theta 1 is? I do not see the chat window now, so just maybe you can open if you want to answer, maybe you can open your microphone and just orally give an answer if you want. So let's go. Theta 1 is the angle, I am looking at this, theta 1 is the angle between x0 and x1. Now we said x0 and x1 are coincident. Both of them are coming out of the paper. Therefore, it's going to be 0. And what about the theta 1? So alpha is 0. Alpha 1 is 0. What about sorry. Let me answer, because there are two questions. One is here, one is here. But first of all, let's answer the theta 1. Theta 1 is the angle between x0 and x1. It's about the z-axis. So x1 and x0 are coincident, so theta 1 is 0. So first of all, this is 0. So what is the second question? This question mark is. Let's see if we have it in the second. This question. Angle between Z2 and Z3 along Z2. Also along X2. So X2 is here. Z3 is coming out of the paper, as you see here. And Z3 is coming out of the paper. Z2 is in this direction here. So if I write it here, obviously I see a 90 degrees of angle. But is it positive or negative? So I figured out the value of the angle. It is 90 degrees. But the question is now, is it positive or negative? All right. So you see, if I use my right hand, let's close Z2 over Z3. My thumb is going to show downwards, not in the direction of X2, but it is going to be in the direction of -2. Therefore, I am going to put a minus sign in front of my angle here. So it's going to be -90. So what's going to be theta 2? So let's again read from here. Theta 2 is the angle between x1 and x2 along z2. Between x1 is in this direction, which is out, so this is x1. x2 you see here, x2 here, it is in this direction, so x1, x2. And about z2. So z2 is this. So if I close x1 over x2, that means I put my right hand so that my fingers are going to be from x1 to x2. So my thumb is going to be showing along negative z2. Okay. Therefore, this angle is 90 degrees, but it is sine is going to be -90. So I put -90 here as theta 2. Now, let us look at the third row. What is theta 3 here? Now again, let us read from here. Theta 3 is the angle between x2 and x3. x2 and x3. Between x2 and x3, the angle is 0, isn't it? Because they are collinear, x2 and x3. So theta 3 is going to be 0. And can we look at the other parameters? Alpha. Alpha is the angle between when alpha is 2, it's going to be the angle between Z2 and Z3. Z2 and Z3. course, the angle between this Z2 is going in this direction and Z3 is coming out is going to be 90 degrees. Again, by using the right hand rule, okay, and it should be along x2. So if I use the right hand rule again, the x2 is upwards, but my thumb is going to show downwards. So it is minus 90. Okay. So A is the distance between, okay, here it's A2, the distance between x2, so it's a distance between Z2 and Z3. So the distance between Z2 and Z3, as you see here, we showed it by L2. So this is going to be L2. A is going to be L2 here. All right. Let's come to D. D is actually happens only if there's a if this was a prismatic joint also if I would have a D, I could just since it is revolute joint here, I can just write 0 here. But this is one way of answering it. The other way of answering this is just use this definition here. So D3, I is 3, D3 is the distance between x2, which is this one, and x3 along Z3. Z3 is here, it's coming out of the paper. So they have a distance along the paper. But since they both are lying on this paper, they have no component in the z direction. So there is no distance along z, no distance along z3. Therefore, it is 0. So we can see it both ways. We can see since this is not a prismatic joint, it is 0. Or we can just use the definition here and we can again see that it is 0. Okay. Now we have got 2 more parameters or 2 more set of parameters or 2 more x's, 4 and 5. Okay, 4. X is 4. Now when I am talking about x is 4, I am talking about the revolute joint. Therefore, I am going to get the parameter of revolute joint theta 4. Since there is no prismatic joint, it is going to be D is going to be 0. Okay. Now the twist angle between the Z3 and Z4, is, as you see, 90 degrees. Because Z3 is coming out of the paper, Z4 is going in this direction along the paper, so there's an angle of 90 degrees in between. Is there any distance? I mean, is there any A parameter? Since they are intersecting each other, there is no distance, so this one is also 0. Okay, there is an angle of 90 degrees between Z4 and Z3. There is no distance between Z4 and Z3 because they are intersecting. There is no D distance because the joints are all revolute. And there is a theta which comes from the angle theta 4. So this leaves us with only one line now. Here, let us look at the alphas. Alphas are the twist angle between Z4 and Z5. So they are parallel. There is no twist between them, 0. The distance between them is along the x-axis is L4, which is this. But there is also a distance by L5 in this direction. Okay, so let's see how D is defined. D is defined as the distance between x5 and x4. So x4 is going to be here, which is 0, but there's an x4 here. This x4, as you see here, and x5 is here. So between them, between the origins, there is a distance of L5. So we put L5 here. Okay, and at the fifth joint, there is no revolute joint, so the theta here is also going to be 0. So this is the table that we have obtained. Now, I would suggest you to close this table and try to drive this table on your own. And whenever you run into difficulty, please watch this part of the video again and see how that part is resolved. If you still cannot find or cannot convince yourself, then in the next lecture, at the beginning of the next lecture, please ask it as a question.